So, students, in this video, I will talk about the vector algebra because I have covered so many topics in maths and physics where we have widely used the vector scalar products and vector addition and vector subtraction. However, this small video will help you to understand the basic so that it will help you to understand and grasp the basic concepts of the basic concepts in physics, like what we have explained about the magnetic flux, electric flux, and Gauss's theorem. So, vector algebra, in this we will cover vector addition, vector subtraction, and the vector products. The vector product means it will have a dot product and a cross product. I have very briefly covered all that, which will help you to understand all these topics which I am covering in my forthcoming videos and what I have covered in my previous topics. So, vector, you must understand what a vector is: any physical quantity which is measured by its magnitude and direction, displacement, velocity, acceleration, momentum, force, etc. So, all these will have a direction also. Whereas speed, distance, work power, magnetic and electric flux, what we are talking about, they are all measured in quantity. There is no direction to this. So, these are called as the scalar quantity. Now, the vector representation is given by, as you can see, it is given here by an arrow. It is an arrow mark here. So, the direction of the arrow will give the direction of the vector, whereas the length what we represent will give the magnitude. So, arrow will represent the direction and length will represent the magnitude. Just to understand, I have covered one example where there are two forces F1 and F2. So, force, as I have already explained, it's a vector quantity. Force is a vector quantity. So, force, there are two forces. There is force F1 which is acting in the x direction, which is very, and this is very, it is a smaller force than F2. F2 is acting in the y direction. So, both the representations I have done. So, vector representation is done by this. So, what is the addition of these two forces F1 and F2? So, for that, I am drawing first vector F1 in its magnitude and the direction, and from the head of this, I am drawing another vector F2, this vector F2 in the direction whatever is given in the question. So, from the head of the second vector and then from the tail of the first vector to the head of the second vector, this one will give the magnitude F is equal to F1 plus F2. Here, for the simplicity, I have taken both vectors where the angle between them is 90 degree. So, you can see the hypotenuse will give the magnitude of F1 and F2, and the direction will be given by the angle theta from the x-axis. There is a one axis which is considered. So, if F1, if I say the direction of F1, it is in x direction, so theta is 0, F2 is 90 degree, and F is equal to F1 plus F2 will have a direction given by tan theta, which is given by F2 by F2, and theta is tan inverse F2 by F2. Now, in this case, if I have to do F1 minus F2, F1 minus F2 means F1, F1 plus minus F2, minus F2. Minus F2 means magnitude is same, but its direction is reverse. So, you can see here it is minus x direction. So, F2 has become the minus x direction. So, F1 I have drawn. Again, I have used the concept of addition plus minus F2. From the head of the F1, I have drawn minus F2, that is opposite to F1, F2, which I have drawn in last figure, and therefore f1 minus f2 will give the f dash. I am calling it as f dash because f is the addition f1 plus f2, here it is f dash. So, from the tail of the first vector to the head of the second vector will give the direction of f1 minus f2. So, what is the angle with respect to the x-axis? If I am writing, it will be tan minus theta because it is in the opposite direction. Tan minus theta is f2 upon f1, you know, or tan minus theta is minus tan theta dash. So, f2 by f1. So, tan 2 pi minus theta dash, and this in the simple mathematics we have solved to find out theta dash is 2 pi minus theta. 2 pi minus theta, which you can understand. Theta, if you have to understand from x-axis, this will be the angle. This will be the angle. This will be the angle, correct, with respect to the same angle we have got. So, this will give the direction of vector f dash is equal to f1 minus. So the another way of adding the vector is a law of parallelogram. If there is two vectors A and B which I have drawn with their magnitude and direction, so the addition is, if we draw vector a1 a like this and b like this, then the diagonal will represent a plus b. The diagonal will represent a plus b. This is law of parallelogram. Here you can see that b is driven. So for addition, this b I have shifted to this place. For the addition means from the head of the a I have drawn b, and then a plus b is drawn, which will represent the direction and magnitude of a plus b. So this is law of parallelogram. What is a minus b in this case? You can say a is drawn like this, b is going up. Here b I have taken down. Here it is going up, so taken down. So a minus b, again it is a plus minus b. So from the head, from the tail of the first vector to the head of the second vector, I have drawn this. So this is a minus b, and it is the resultant vector r dash is a minus b. Here it is a plus b. So law of parallelogram holds like this. Okay. So you can say a minus b in the law of parallelogram. If you the second diagonal, if the second diagonal, you can draw it like this. Okay. So this figure you have to understand, and this also, this will give a plus b, and this will give a minus b. This will give a minus b. A minus b, because this will be widely used in physics while solving many of the problems. Now we come to the vector product. One is the scalar product. Scalar product means dot product. So displacement vector, so work done is given by force dot displacement. So force dot displacement will give the work done. Here it is, F is force vector, D is called as the displacement vector. For an example, if the force is acting in horizontal direction and displacement is happening in this direction, then if I do the dot product F dot D, so I have drawn F and D, and there is an angle theta between them. So D cos theta will be the projection of D onto F. It is projection of D cos theta will be the projection of D in the direction of F. So F dot D will be given by F into D cos theta. That is product of force and displacement and projection of displacement in the direction of force. So this is how we do the dot products, like we have done in the Gauss's law. If E dot A is nothing but E into A cos theta. If this is an area, so area vector will be perpendicular to the area, and electric field is going in the horizontal direction. There is an angle theta between them. So E into A cos theta. So or you can write as E cos theta into A. If I take area vector in this direction, then component of E in the direction of A, component of E in the direction of A into A. So that will give the flux, electric flux. Similarly, magnetic flux is calculated by B dot A, where B is also having a direction, A is also having a direction, both are vectors, but their product is phi B, which is a scalar quantity. So hope you would have understood what is vector dot product. Now I will come to the vector cross product. These are widely used concepts in physics. And then vector cross product. Vector cross product is represented by A cross B. A is a vector, B is a vector. So A cross B is given by vector, is nothing but vector cross product. So A cross B is nothing but A B sine theta and n cap. N cap is a unit vector in the direction of A cross B. If there is any vector A cross B, then what is n cap is a vector in the direction of A cross B. So A cross B will also be a vector. The product, the dot product will result in the scalar quantity, whereas the cross product will represent in a vector quantity. So like torque is nothing but R into F. The torque acting on a particle is equal to the vector product of the position vector and the force. You know, if there is a R vector and there is a force F, there is a force F. So R is acting and force is acting in this direction. So torque will act perpendicular to it. So torque will be given by R cross F. So what we have to note in this is these two vectors A and B are R cross F in the same plane, but the torque will be perpendicular to both F and R. So this is the concept of a cross product. A cross B is perpendicular to both A and B. Here I have drawn a plane. A and B are in the same plane where they are rotating in the, you can see theta is, I have marked the theta. So theta, the rotation is happening, if you can say, this is how the rotation is happening. This is how the rotation of the plane is happening. So n cap is the vector. I have already told it is a unit vector in the direction of A cross B, and A cross B will be this vector. A and B, if they are these vectors, then A cross B is perpendicular to both A and B. It will be perpendicular to both A and B, and the value of this unit vector will be given by A cross B divided by magnitude of A cross B. Magnitude. Here the, if I am writing A mod, means this is magnitude. This is a mod sign. Mod sign will give A cross B. Here, since now if I rotate it in the opposite direction, if I do B cross A, if I, then what will happen? The direction of n will go opposite. The direction of n will go opposite, and B cross A will point in the direction of negative z direction. Here it is the negative, positive y direction, positive z direction. Here it is in the negative z direction. So A cross B will be nothing but minus B cross A. So you must understand this concept, because this will help you to grasp many topics in physics, because I am explaining this from the perspective of understanding the concepts in physics. Whereas if you understand the maths, we will come to the vector algebra also, which will be covered in detail in our other lectures. So vector algebra of the unit vectors, very shortly I am covering, because any vector is represented by its magnitude and direction, as I have told. So A is, mod A is called as magnitude of A, and the unit vector in the direction of A. So this is a unit vector in the direction of A. So any unit vector in the direction of A will be represented by this sign. It is A divided by mod of A. So same I have used here. Here the unit vector in the direction of A cross B will be nothing but A cross B divided by mod of A into B. Now, I am now talking of the vector algebra of unit vectors. Now, if there are x, y and z direction, three z directions, A, x, y and then z direction. If it is x, this is y, and this is z direction, there is a unit vector I, j and k. There are three unit vectors. Unit vectors means they have a magnitude, unity, and they will point in x, y and z directions respectively. So, if I have to draw any vector in xy plane, so what will be happening in the xy plane? I am drawing a vector E. There is an Ax which is in the x direction and Ay component which is in the y direction. So Ax and Ay component. So vector is represented by Ax into I cap plus Ay into j cap. So Ay into j cap. So this A can be represented, resolved into two vectors. One acting in the x direction Axi, and another is Ay into j. And the magnitude of A, of course, will be given by, you know, Pythagoras theorem. This is the total length of the vector A will be given by Ax square plus Ay square. So this is magnitude. So if I have to find out the unit vector in the direction of A, it will be given by vector A divided by mod of A. So vector A divided by mod of A. So I am just separating out Ax divided by under root of Ax square plus Ay square into I cap plus Ay divided by under root of Ax square plus Ay square into j, which you can understand from the trigonometry that this is given by cos theta, because it is based upon hypotenuse. So this is cos theta I plus this is perpendicular upon hypotenuse. So this is given by sin theta, and you know sin square theta plus cos square theta is 1. So this is a unit vector. Correct? So hope you would have understood what is the unit vector and what is how the unit vector algebra applies to the vector in a plane. So I'll briefly tell about the vectors unit algebra of the vector in the three dimensional. So I'll only explain about the vector. So A is equal to Axi plus Ayj plus Azk, because now there are it is a three dimensional vector. So it will have a component in the z direction also. So this will be represented by Axi plus Ayj plus Azk, and from the similar concept of the planar vector, its magnitude will be given by Ax square plus Ay square plus Az square. So I have done the representation of this. I have done the representation of this in this direction, and I can also write what is the unit vector in this direction, which is I can write is Axi plus Ayj plus Azk divided by under root of ax square plus ay square plus az square. Hope you would have understood the vector algebra. So we'll come up with the more topics in physics in our coming lecture.